Hello, welcome to today's lecture. Before we begin, I am going to present you with some scenarios. Has it ever happened to you that nobody is at home and you have forgotten your house keys and cannot get in? Have you been stuck in traffic and getting late to catch a train? Or had a fight with a friend who is now refusing to talk to you? You may have experienced all of these or one of them. Were you successful in coming up with a solution? Whether you were successful or not, what you have indulged in is problem solving. Problem solving is the topic for today's lecture. At the end of the lecture, I hope you can identify which strategy will be the best in solving the problems in the scenarios I just mentioned. However, before we get to that, let us understand the stages involved in problem solving. Problem solving refers to the efforts to develop or choose among various responses in order to attain a desired goal. It occurs when a goal is reached by thinking and behaving in certain ways. It is considered to be a type of decision making. In everyday life, we are faced with a wide range of problems. Whether it is a child trying to tie her shoelaces on her own, someone trying to solve a crossword puzzle, or scientists coming up with a solution to reduce carbon emissions and protect the environment. The problem may be well defined or ill defined. Well defined problems are those which have a clear starting point and a correct solution. They often also include a set of rules. For example, problems in maths, fixing a punctured tire. In such problems, the process involved in solving the problem is clear, and so is the solution. An ill-defined problem is the one which does not have a clear solution or a single correct answer. For example, deciding one's career path. Here, there are multiple possibilities, each with pros and cons and no right answer. In everyday life, most problems we face are ill-defined. Stages of problem solving. How does problem solving take place? This is a question cognitive psychologists have tried to answer, and they believe that it involves 4 aspects. We will now understand what these are. The first stage is problem identification. As the name suggests, it means recognizing that a problem exists. This involves trying to understand what the issues, obstacles, and goals are. In some instances, this is easy. However, sometimes identification may be more complex. Let us take an example. Rajesh is routinely missing school. Why is this happening? Is it because he falls ill often? Is he being bullied at school? Does he oversleep and miss the school bus? Is going to school not a priority in his house? Unless the problem is correctly identified, it is difficult to progress to the next stage in problem solving. Stage 2. Formulate potential solutions. Identifying the problem does not mean that a solution will immediately be found. The next stage is identifying potential solutions. This is an important stage and one that highlights how our cognitive processes are interlinked. In order to come up with probable solutions, we have to rely on information that is stored in our long-term memory. Since solutions to problems depend on the information we have at our disposal. This helps us in coming up with more solutions to the problem and increases the likelihood that we will reach the goal. If Rajesh is missing school because he oversleeps, what could the solutions be? Some of the potential solutions could look like: look for an alternate mode of transport if he doesn't miss the bus, no screen time after 7 p.m., create a routine which ensures that he eats dinner and sleeps at a reasonable time. Stage 3. Evaluate each alternative. After we have some solutions, we need to evaluate them. Will a particular solution help us reach a goal? Think of this step as a cost-benefit analysis. Here, we need to judge the advantages and disadvantages of each alternative. Questions we might ask are: is the solution the best one available to us? Are there any costs or disadvantages involved? What are the potential obstacles? Let us evaluate the solutions. Solution 1. Instead of the school bus, Rajesh's mother drops him to school. However, this would mean that she will get late to work herself. Here, the costs involved is too high for this to be a good solution. Solution 2. No screen time after 7 p.m. will be hard to enforce as everyone watches TV shows at night. As Rajesh is too young to be left alone, watching TV with the family is unavoidable. Solution 3. Ensuring that there is a routine that Rajesh follows every day. This includes physical activity in the evening, meals at a fixed time, and sleeping and waking up at the same time every day. The benefit here will be more structure and inculcating good habits. The costs would be more effort and discipline involved. In this case, the benefits outweigh the costs. Thus, creating a routine seems like the best option. This brings us to the last stage, trying potential solutions. Unless we put our solutions into action, that is, implement it, we will not know if it is effective. Setting a routine which is agreeable to Rajesh and his parents will likely result in success. However, many times a solution might not bring us to the goal itself, but gets us closer to it. It is necessary that we examine the effects of the solutions on problem solving. Now that we have understood the steps in problem solving, let us evaluate some of the methods that are routinely used to solve problems. Trial and error. Have you ever tried making a roti or chapati? This involves kneading the dough, rolling it out and cooking it. Anyone who has will know that making one is deceptively simple. Getting the consistency of the dough right, being able to roll it into a circle and keeping it on the flame for the right amount of time is a skill that one perfects after making it a few times. Each time you make a roti can be thought of as a trial. Based on the kind of roti you create, you change your technique to make a better version of it the next time. This is how problem solving via trial and error takes place. In this method, an individual tries different responses or possible solutions one after the other until a successful one is found. This method can be very time consuming. For example, Thomas Edison tried thousands of light bulb filaments before getting the right one. Often, we adopt this method when we do not have enough information for a more systematic approach. Trial and error method of problem solving is widely used, but does not always guarantee a solution. Have you ever forgotten the PIN to unlock your phone? You try different combinations of numbers, but after 5 unsuccessful attempts, you will be locked out of your phone for some time. Algorithms. When we think of the word algorithm, what comes to your mind? Maybe you are thinking of computers and programming. While that is correct, you might be surprised to know that we use algorithms in our daily lives to help us solve problems. Algorithms refer to step-by-step methods to solve a problem that will always guarantee a solution. Using an instruction manual to build a piece of furniture is an example of an algorithm in problem solving. If you follow the instructions as given, you will be able to build a table without any trouble. The use of algorithms results in a solution, but it can be burdensome. For instance, you can try every combination of numbers from 0 to 9 to find the 4-digit PIN for your phone, but can you imagine the amount of time that would be required? Let us take a minute to reflect on what you would do in this situation. Trial and error methods and algorithm methods to problem solving do not seem like the best methods for this situation. Can there be a way to tackle this problem? This brings us to the next method of problem solving, heuristics. Heuristics. Remember the previous examples of trying to crack your phone PIN? Instead of trying all possible number combinations, you will narrow it down to some combinations that have special meaning for you, like the birth years of family members, your vehicle number, numbers for the postal PIN code, etc. In this case, we are trying to solve the problem using an educated guess. An educated guess involves prior experience and is thus likely to be correct. Most often, we will set the PIN based on numbers that are easy for us to remember and not a random combination. In this case, we have used heuristics, also known as rule of thumb, to solve the problem. Unlike algorithms, this method may not always lead to an answer, but narrows down the possible solutions. Despite this, why do we use heuristics? Because what heuristics lack in terms of guaranteeing a solution, they make up for in efficiency. It is less time consuming compared to the previous methods. Analogy. This is an effective method which uses prior information in problem solving rather than starting afresh. In this method, we detect similarities between the current problem and problems solved in the past to come up with a solution. Gick and Holyoake conducted a study to understand problem solving techniques of reasoning by analogy. They asked participants to solve a medical problem. A doctor had to treat a patient with an inoperable malignant tumor. This tumor could be treated by high intensity rays, but it was powerful enough to destroy the tumor and also destroy healthy tissue. A less intense ray would not harm the healthy tissue, but was also too weak to kill the tumor. Some of the participants read a story before being given the medical problem. The story was about a general who was trying to capture a fortress from a dictator. This fortress was surrounded by roads with mines that could kill the army if they marched on any one road leading to the fortress. However, the general realized that if small groups of soldiers walked over the mine roads, they would cross it safely. The general devised a plan of breaking up his army into small groups who would use different roads to reach the fortress at the same time and then attack it. He was successful in overthrowing the dictator using this plan. On the surface, the story about the general and the tumor problem appear to be different. However, the underlying structure is the same. The tumor can be thought of as a fortress. The general used small groups of soldiers to capture the fortress while protecting his men. Likewise, the doctor can use multiple rays of less intensity, all converging on the tumor, killing it and protecting the healthy tissue. Participants who were told that there is a similarity between the problem and the story were more likely to solve the problem than participants who were not given the hint. This study shows how using analogies aids in problem solving. We use this strategy to solve problems in our life too. Imagine you are driving in a new city and you have a flat tire which needs to be fixed. You do not know where the mechanics shops are, but you know that almost all petrol pumps have mechanics who can fix a tire. So you start looking for a signboard for the nearest petrol pump, and if you find a repair shop, you have successfully solved the problem using the analogy method. Insight. The last method in problem solving we will be looking at is a very interesting one. Instead of relying on a stepwise method to arrive at a solution, in this method there is a sudden awareness which leads to a solution. Before we go further, let us do an activity. You will need a paper and pen for this. As you can see, there are 10 coins arranged in the shape of a triangle. Your task is to move any 3 coins to make the triangle point downwards as shown on the screen. Could you solve it? If you were not successful, do not feel too bad. It is a hard one. Here is the solution to the problem. This task is known as the triangle of coins by de Bono. It is a classic example of problem requiring insight. It is seen that people trying to solve the problem usually make a few unsuccessful moves until the solution for the problem suddenly appears. Insight is often referred to as the aha moment. There is a sudden flash of comprehension that occurs and leads to a solution. Insight refers to a sudden awareness of the relationship among various elements that had previously appeared to be unrelated. It is very important to remember that this method of problem solving is not a magical one, though it may appear like the solution came out of nowhere. In this process, there is an initial phase of trial and error where there are multiple unsuccessful attempts, like you might have experienced in trying to solve the triangle of coins problem. The solution seems to appear in a sudden flash because the mind is reorganizing the problem while we may be thinking of something else. Now that we have learned about the different methods that are used to solve problems, try answering this. Identify which problem solving method is the best one in the given situations. While playing a game of tic-tac-toe or noughts and crosses, Roshan always starts from the center square. Which problem solving method is he using? Your mobile phone is not working. In order to fix it, you try the following: restarting it, removing and then inserting the SIM card, cleaning the surface of your phone to remove dust and dirt that might be stuck. Rita is late. Instead of using her usual route, she uses the Google Maps app to help her navigate and find the fastest route from home to college. As a manager, David has to solve a conflict between his employees. He decides to use a similar strategy that has been successful while solving conflicts with his siblings. Marsha and Marjorie were born on the same day of the same month of the same year to the same mother and same father, yet they are not twins. Let us review the answers. A. Heuristics. Roshan's first move in the game is by beginning from the center square. This is a strategy that most of the time results in him winning, but it does not always lead to success. This strategy can be thought of as a rule of thumb. B. Trial and error. When we do not know what response will solve the problem, we keep trying different solutions with the hope that one will work. C. Algorithms. In this case, Rita is using a strategy which will definitely give her the fastest route. The app uses GPS and it also modifies the route based on real-time traffic situation. D. Analogy. David is trying to resolve the conflict based on the belief that human relationships are similar. Hence, even if the context is different, strategies can be the same. E. Insight. Marsha and Marjorie are two of a set of triplets. I hope this exercise helped clarify the methods involved in problem solving. Factors interfering with problem solving. Sometimes, despite our best efforts, we are unable to solve the problem. At times, this could be because of lack of knowledge and experience. However, there could be other powerful forces that act as barriers. We will learn about two such barriers in problem solving in this section. Functional fixedness. This is a common hurdle when it comes to problem solving. Functional fixedness refers to thinking about objects only in terms of their typical uses, which leads to difficulty in problem solving. It is the rigidity in thinking, the belief that there is a fixed function for an object that acts as a barrier to problem solving. The problem given by Dunkirk is a famous example of functional fixedness in problem solving. We will look at the problem he gave his participants. The participants had the following objects: a candle, matchbox and pins, and were asked to attach the candle on a wall so that it is upright, it burns and the wax does not fall on the floor. They had to do so using only the objects given. Take a minute and try to solve this problem. Maybe you thought of using the pins to attach the candle to the wall. This may work, but it might result in the candle breaking in two and the wax falling on the floor. But often people overlook an easier solution: emptying the matches from the box and attaching the box to the wall with the pins. This creates a makeshift table and then placing the candle on the box. Very often we fail to see this solution because we do not think of the matchbox as a substitute table-like surface. We are unable to view the box as anything but a box. In reality, the structure of a box is similar to a table, yet we are unable to quickly make this connection, not because we are unintelligent, but because of functional fixedness. The ability to overcome functional fixedness can lead to some creative solutions to problems. If a table is wobbly and unstable, a quick solution is to fold sheets of paper and wedge it under the leg of the table. This is an example of overcoming functional fixedness. That is, we no longer look at paper as something that only can be used to write on, but something that serves many purposes. Mental set. Let us start with a small activity. You will need a sheet of paper and a pen. Draw 9 dots on your sheet like the ones you see on the screen. Your task is to draw 4 straight lines so that they pass through all 9 dots. While drawing, you have to ensure that you do not lift your pen from the paper and do not touch any dot more than once. Okay, now let us look at the solution. Were you able to solve this problem? This task is known as the 9-dot problem. If you were not able to solve it, do not worry, you are not alone. Mental set is most likely to be the culprit here. Mental set refers to the impact of past experience on present problem solving. It is the tendency to retain methods that were unsuccessful in the past, even if better alternatives now exist. In the 9-dot problem, it is likely that we view the dots as forming a square and we use the 4 lines to complete it. On the other hand, if we are able to break free of this, we can easily come up with the solution. When we solve similar problems, we get to using one strategy. And then when we are faced with a problem framed similarly, but one that requires a much simpler solution, we cannot think of it. We continue using the same strategy that we used earlier. In today's lecture, we have looked at various aspects of problem solving, which is a special type of thinking. We began with the definition of problem solving and described the 4 steps involved, namely identifying the problem, identifying potential solutions, evaluating potential solutions and implementing the solution. We also learned about the methods involved in problem solving: trial and error, algorithms, heuristics, analogy and insight. By selecting the appropriate method, we can increase our efficiency in problem solving. Finally, we learned about 2 of the common barriers that we experience when trying to find a solution to the problem, namely functional fixedness and mental set. If we are aware of these barriers, we are also better at overcoming them. And before we end, I would like to draw your attention to the questions I asked at the beginning of the lecture. Are you able to figure out which problem solving strategy will be best suited in each of these scenarios? Let us answer before we conclude. Has it ever happened to you that nobody is at home and you have forgotten your keys and cannot get in? In this case, trial and error might be the most effective. 1. You could call your neighbor for help, try another key, or go to the locksmith to get a duplicate made. Have you ever been stuck in traffic and getting late to catch a train? Using algorithms by checking the fastest route on an app like Google Maps will be the best strategy rather than any of the others. And the last one was, had a fight with a friend who is now refusing to talk to you. You might have guessed this one, analogy. You could use a strategy similar to the one you used in other relationships to resolve the conflict. I do hope this lecture helped you understand the concept of problem solving. And you will be able to apply some of the methods of problem solving in your daily life while being aware of the potential hurdles in arriving at a solution. Thank you.